In this video, I'm going to show you how to implement search functionality in React.js. And not only that, I'm also going to show you how to add infinite scrolling to it. And after that, I'm also going to show you how to optimize your search functionality by adding debouncing to it. So debouncing is just going to optimize everything. It's going to optimize the number of times you hit the API call, and ultimately it's going to make things a lot more smooth. Now, this is asked during the interviews of many big tech companies, where they ask you to implement a search system that should include infinite scrolling, and it should also be optimized. And the best way to optimize a search functionality is by using debouncing in JavaScript. And I'm going to show you how to do all of that in this video itself. So without any further ado, let's get started. But first of all, before I dive into the code, I'm going to show you the demo of what we are going to build. So over here, you can just see a search input on the screen. I'm going to zoom in a little bit. You can see this search input on the screen, and when I start writing something to it, let's say I'll write T 2 times. I wrote T, it says loading because it's fetching the data from the API, and then once everything is loaded, you can see a list of all data items are presented to you on the screen. So when we write TT, the API is called, we get all the items on the screen, and then the next step is to add infinite scrolling. And in infinite scrolling, what happens is once we take this scroll bar to the bottom of the page, we want the next set of data from the API to be loaded and fetched so that we can display it on the screen. So in infinite scrolling, once we reach the bottom of the screen, we will again call the endpoint, and that will just add more data into our screen. So to show you the demo of that, I'll just take the scroll bar right till the bottom, and once it reaches the bottom, you can see loading is displayed again because it's calling the API and loading the rest of the data. And then you can see the data loaded and the scroll bar went to the top again. This means the data got loaded and you can see more data coming through. Now if I go to the bottom again, you're going to see loading displays again, and things are going to be loaded again. It's going to wait. Once things gets loaded, the scroll bar goes up again and more data has been loaded up. So this is nothing but infinite scrolling. Now, just to show you that I've also optimized these calls, I'm going to show you the proof that debouncing has also been added to this search functionality. So what I'll do is I'll just refresh this and I'll open my network. I'll go over here, I'll open my network, and then I'll just zoom out of here a bit. Now, you're going to notice something. Now, once I start typing on this input, what used to previously happen is if I did not optimize it, then on each letter I would be calling the API endpoint. After each letter that I type, I would be calling the API endpoint. So suppose, consider I type something like home. So for like each of those letters, it's going to call the API endpoint. So in total 4 times that API would have been called, which is not a good approach. So I just implemented debouncing over it. And what debouncing does is once the user stops typing after a particular delay, only then the network call will be initiated. So now to show you what I mean, all I'm going to do is I'm going to write ABC over here, and you're going to see the endpoint being called only once. So I'll type ABC, and you see the endpoint gets called only once, and then it's in the loading state. And this API is a little slow, but once it ends up fetching all the data, you can see all the data gets displayed over here. So it did not call the API for each of these letters. It just called the API once I stopped typing. So I'm also going to show you how to debounce this search input by reducing the number of network calls we make. So this is all you're going to learn in this video. So without any further ado, let's get started. Alright, so over here you can see this basic setup created. I just used npx create react app, and I deleted some of the files that are unnecessary, and I just have this app.css and this app.js file. And all the logic is going to go within this app file, since this is not going to be too much of a huge code, and we are only focused at writing the code in a clean and understandable manner. We don't need to create components and all over here, since I'm going to try to code it in the best way possible, considering that this has been an interview. So we're not going to create different components. We're going to do everything in this file itself, and it's going to work along fine. So first of all, to get started, let's just add the input field first. So what I'm going to do is I'm going to change the name of this app first of all to, let's say, search container, and I prefer this being in small. And after that, I'll just go ahead and add the input. All right, now the input will have a type of text, and then after that I can just add an on change, and this on change will take an event, and we will call a function handleChange. This will also take an event. This will take this event from here, from the callback, and let's just create this function handleChange, and the function is created. Now I'll add the logic for the handle change. That's going to be pretty simple. For all that, first of all, I'm just going to import React from here. I'm going to say import React from React, and I'm going to get the use state. All right, now I'll create a state. I'll just name it query and then set query, and this will be initialized with an empty string. Now all we need to do is handle change is going to take an event e coming up from here, and then I'll just set that the value within that target coming from the event within this set query. I'll just say e.target.value. I'll save this. Now if I just console.log query, you'll be able to see the query getting added to query state. So if I just go to my browser and I open the console, then here you can see as I type, I'll say ABC, you can see ABC gets added to the query. All right, so we have that. So now our query includes the value that we are searching for. So when we finally call the API, we can send this query to it. So for that, let's call the API, and to do that, we will call it within the useEffect. So let's import useEffect. All right, and then right under here, I can write useEffect. All right, and this useEffect is going to be called when the query changes. Every time the query changes, we want to call the API. So all I'm going to do first of all is I'll make another state. I'm going to copy this, paste it here, and I'm going to call this loading. I'll set it to loading. All right, and within the useEffect, what I'll do first is set the loading to true, and this needs to be initialized. The loading needs to be initialized with false. So when we call the API, the loading state becomes true. So we will be calling the API within this useEffect. So the moment we enter this useEffect, whenever the query changes, the set loading needs to become true, because obviously the loading needs to be in true state. And after that, what I'll do is I'll make a function. I'll call it get search items. Right? This will be an async function, and then I will just make this a function, and at the end I'll call it right over here. Now within this async function, we are going to call the API, we are going to await the response, and then we are going to add it to our state. Now we need to add whatever data that comes from the API to a state so that we can map it down within this return in the end, right? So for that, what I'm going to do is I'm going to make another state, and I'm going to call this data set data. This will be use state, and this will be an empty array. So within this get search items, I'm going to call the API by using Axios. Now for that, first of all, we need Axios to be installed. So all I'm going to do is I'm going to say npm I Axios right over here. This is going to install Axios, and then we are just going to import it. All right, so Axios has been installed, and all I'm going to do is I'm going to import Axios over here. Import Axios from Axios. Now this is going to help us call the API. You could also not use Axios if you want. You could just use the normal fetch that's provided by JavaScript, but I'm going to use Axios in this case. So all I'm going to do over here is I'm going to say let's call this shows. Whatever data the API returns, I'll just add it to this variable named shows. Okay, because this API is actually getting the list of shows, the list of TV shows, and this API is going to be paginated. So what that means is, for to do infinite scrolling, you need to make sure that the API you're calling is paginated, because the API requires a query and a page number. So whenever we hit the end, whenever we scroll down to the end of the page, we increment the page number. So we call page 2 to the API along with the query, and the API will send us the next set of data, which is nothing but the page 2 for that particular query. So that's why you need to use a paginated API. So I have found a paginated API, and I've got it from Open Library. And to show you how it works, I'm just going to write over here first await axios.get. Now within this get, I'm just going to paste the API. I'm going to add this curly string, and I'm going to paste this API, and then this API takes two parameters. Then this API takes two params. You can read in the documentation of Open Library search.json. It requires two params. One is the query and the second is the page. So now this API, as per the documentation, takes two parameters. If you want to use the pagination, it requires two parameters. One is the title and the other is the page number. So for that, what I can do is I'm first of all going to write over here, I'm going to make another state page, and I'm going to say set page, and this is going to be a use state, and it's going to be initialized with 1 in the beginning. All right, so what I'm going to do next is, in this API, all I'm going to say is, I'm going to write a question mark, and the first parameter is title. So I'm going to say title equals to where the $sign. I'm going to send the query, right? Because our whatever we search, that is the title, right? That's the title we're looking for from this API. And then after that, I'm going to say and I'm going to add the next parameter, the next params basically, which is page, and this is going to be equal to the page number or the page state that we created here. All right, so this is going to make sure that whatever query I add over here and the page, it gets appended along with this API, and then the API searches based on these parameters. So since we're awaiting over here, once Axios returns the response from this API, what's going to happen is we can do set loading false, because once the result has returned, we are not loading anymore, so we are setting it false, and then we are setting the data over here. Now it's important to remember that this API can sometimes return multiple titles which having the same name, and we don't want that. In this case, we just want all titles to be unique. So what I'll do is I'll add the result, whatever shows returns, I'll add it within a set, because the set will always make sure that it always has unique values. All right, so I'm just going to say if there's any previous item, I'll just say priv, and then all I'll do is this will be a callback. Within that callback, I will return an array, and within this array, I will spread out a new set. Now within this new set, I'll initialize the values in the following manner. I'll just spread out all the previous values, and then after this, all I'm going to say is I'm going to spread out, sorry, my bad again, I'm going to spread out shows dot data dot docs, and then I'm going to map through the docs that's returned by the API, and then for each show, I'm just going to return the title, the show dot title. All right, now how do I know that this is going to be shows dot data dot docs? Because if I just console log the shows over here, you'll see what I mean. I'll console log shows, go to my browser, and then over here you can see within shows there's something called data. If I expand data, then within that data we get all the docs, and within this docs we are going to have all the elements for whatever search term we search for. Just to show you an example, I'm going to write ABC, and now you can see the data coming on, and if I expand this data, you can see the number found is this much, and the docs is populated with 100 items, right? You can see 100 items. That's why I did shows.data.docs.map, and whatever previous value we had in this data, in this set data, in this data variable, basically we are also spreading it along that. So the set data will have a new array which will have all the previous data plus all the new data. Whenever we scroll down, if there's more data coming through, then it will have previous data that came from the previous page numbers plus the new data, and it will only include the title, and we're adding it all within a set so that the values stay unique. And also one more thing to note is over here, this start in the API, it just indicates the page number kind of. I mean, you don't need to focus on this, but this start just means that when the start is 0, that means we are in page number 1. And then if I go to page number 2, then it's going to give the next set of 100 documents, and this start is going to become 100 in that case. It's going to be the starting of the index of the current number of documents that we are seeing. So if start is 0, it means it's the first set of 100 documents starting from 0. But then when we go to page number 2, this start is going to become 100, and this docs will have 100 items, and when this start is 100, it means we are in page 2. Don't worry, you'll get clearer with this later on, but you don't need to go deep into this because we just need to pass the subsequent page numbers over here. We are not quite bothered with what start says. Alright, so I'm going to remove this console log, and now since our data has all the data, what I can do is I can just map through that data over here and start displaying the items. I'll also remove this query. And before we proceed, I just realized when I expanded this API, I realized these are not shows, but these are books. So just to avoid confusion, what I can do is I can just books over here, and I can replace this shows with books, and I can put book over here, and this can also be book. This is just to avoid confusion for you guys. So these are books. Anyway, we are just appending it to the data. So we can just go down here and we can finally map through the items in the data. So I can say data dot map for each book, and then we're going to also access the index. And for now, I'll just return a div. All right, and this should be returned. and this div will include book, because anyway the data just includes the title. So if I just, so the item book is going to just be the title. And then over here I can also give it a class name. I'm going to say class name of, let's say, search title. All right, and now after doing this, what I can do is I can also give of index, that we don't get that warning basically that each child should have a unique key. And also one more thing we need to do is I need to create another use effect over here, this, and I need to make sure that whenever query is changed, so whenever the query changes, we need to set the data to an empty array, because new data is going to come along every time the query changes, right? So we don't need that old query's data. Now another thing to ensure is this query, along with this query, we also need to pass page over here, because whenever query or the page changes, then we need to call this API, because we are using both of them over here within this use effect. So now before we check if we are getting the data items or not, I'll just add the stylings first of all. So first I need to add the styling for search container and search title as well. I'll be centering everything out. Let me also get search title, and over here styles for that. So for the search container, we just need to center everything out. So I'm just going to say display flex, text direction of column, and then I'm going to give justify content of, let's say, center, and an align items of center as well. And for the search title, we want to have a little bit of space between all the titles, so we'll just add a font size of 18px and a padding to give that space. Padding 10px top and down, and right and left should be 0. So now I'll just save this. I'll go to my browser. Now I'll just type T, and then so things are going to load. The API is going to be called. You can see the API gets called over here. The payload T is being passed to the page 1. This API is a little slow, so it takes some time to send the data. So now you can see the data is received, and we are getting the values in a very weird fashion. Like, so it shouldn't be individual letters like this. If I go to the preview, you can see in the docs, and if I open the title, you can see that where's the title? The title's over here. You can see we are getting the entire title in the data, but we are not displaying it in the right way. You can see I'm getting it can't happen here as the first data, but it seems like over here in the way we are mapping it letter wise. It cant can't happen here, and so on. It's just happening in a very weird way. And I realize the reason for this is because we haven't set this in the right way. So in a set, to be able to initialize these values, we need to pass this within an array. That is how the set takes values. So that was wrong on my part. You need to initialize it like this. If you initialize it like this, then this is how the set takes values. This is the syntax of how set takes default values. Alright, then once we add this within the set will ensure that all the titles are unique. Then we are taking all those values from the set and we are spreading it into this array, and we are returning this array in the end within the set data. Alright, so if I save this and I go to my browser, and now you can see all the titles are available properly. This is exactly what we wanted. Now our next task is, when I take the scroll bar and I hit to the bottom of the screen, when I hit at the bottom of the page, we want that the page should be incremented and the API should be called again. So how do we ensure that whenever the scroll bar hits to the bottom of the page, the API is called again? How do we track that? How do we track the fact that the scroll bar has reached the bottom of the page? Now for that, you need to be aware of something called the intersection observer in JavaScript. So JavaScript provides us something called the intersection observer that helps us observe or track any node element. And based on that, we can check if a certain node or element is visible, or basically if it's intersecting, then we can perform an action. So in this case, what we can do is we can try to observe the last element of the data. So the data includes all these elements. What I can do is I can make the intersection observer observe the last element, which is this. And once we scroll and reach the last element or the last node, only then we want the intersection observer to perform an action, and that action will be nothing but incrementing the page. Because once the page gets incremented, this use effect will be called again, because we have set page as a dependency, and then the API will again be called and the data will be populated all over again with the new data along with the previous values as well. That is what we need to do. We need to make use of the intersection observer. Now for that, all I'm going to do is something like this. I am first of all going to get use ref, and then right over here I'm going to say const observer equals to use ref. Now we are using use ref over here and setting it to the observer because whenever the state changes, whenever the query or something changes, the page number or anything, whenever the loading state changes and so on, React re-renders the component again. But whenever the component re-renders, we don't want the observer state to be lost. If I set this to a state, the observer state will also re-render, and that's a problem. So if I just set the observer to a use ref, even if the state updates, the observer will always persist its data. So if I observe the last element of the data, even if the state changes, the observer will not change and it will keep observing the last element of the data. Alright, so now all we need to do is say something over here like last element. Alright, and within this last element, this is going to be a function, and we need to initialize the intersection observer over here. Now, how do we get the last element? So for that, we need to attach this last element to the ref of that last element of the data. So over here, when we are mapping through the data, how do we check that if it's the last element or not? So for that, what I can do is I can do something like this and write if data.length equals to the index plus 1, then that means we will return the last element. And for that, I'm going to help you understand what I mean. Else, we are going to just simply add this statement over there. Else is going to include this. Alright, so now these two are pretty much the same, but this is going to be the last element. If data.length is equal to the index plus 1, which means if it's the last element, then what we need to do for just the last element, we need to attach a ref and we need to attach it to the last element variable that we created up there. Alright, and for all the other elements, it's just going to be normally returned, but for the last element, we are going to attach a ref and we're going to include the last element variable that we created over here. Alright, this is a function, this is going to perform something, and within this function, we are going to use the observer to observe the last element. Alright, so what happens is when I attach last element over here, then as you can see over here, this last element is taking an argument of node. So when I attach the ref to the last element, this ref automatically gives this last element an argument of that node it is attached to. And since we are only doing this for the last element, so this ref is always going to send the last element as the argument to this function. Alright, so this node is always going to denote the last element. Now what we can do within this is, you kind of need to know how intersection observer works, but you'll get a brief idea over here as well. So what I can do first is, I'm going to say if it's loading, then I simply just want to return. If you're fetching new data and it's loading, then we don't care about it at all. We don't need to observe anything because the last element is still loading. It hasn't come out yet. The next thing we're going to do is if observer dot current. So to access the value of a variable which is declared as useRef, you need to use dot current. So this dot current will give us the value that's within the observer. That's how useRef works. If observer dot current, so if we are observing anything, then we just want to select observer dot current and we want to disconnect from it. So if there's already an observer, then we disconnect from it. We disconnect because we want to observe the new node which has been loaded up recently. That's why we are checking that if loading is true, we just return, but if loading is false, then whatever we were observing before, which was the previous last node, we don't want to observe that anymore. So we are just disconnecting, and for the new set of data that has come up, we want to observe the last element of that node. So I'm going to say over here, observer that current will become equal to new intersection observer. Within this observer, there are going to be entries. So this entries is going to denote all of the things that we are observing. So whatever we are observing, this intersection observer will give us a callback, and within that callback there's an argument entries. So whatever we observe, this entries is going to contain all of those things that we are observing. In this case, we are just observing one element, which is the last element. And also it's important to note that this entries is always going to be an array of nodes, an array of all the things that you're observing. Right, but since we will always have only one element in the entries, in this case, since we're always only observing the last element, so these entries will only have one element. And therefore what we can do is, we can just simply say if entries of 0 dot is intersecting, then we can say set page, and we'll check whatever the previous page was. And then what we can do is, we can do previous plus 1. whenever we intersect, so whenever we reach to the bottom, or whenever we reach towards the element which we are observing, which is the last element, then the page will be incremented. Now you might ask, where are we adding the code to observe something? So that's going to be added over here. I'm going to say if a node exists, right? So this node we are getting from here, as if you remembered, I said this last element will have a node attached to it, and since we are only doing it for the last element, like for the last node, this ref will always attach that last node as an argument to this last element. So we are saying if node exists, then all I'm doing is observer.current.observe, and I'm going to observe that node. Alright, so this is the syntax for intersection observer. You should know how this works. You can also quickly just check it in the docs. It's pretty self-explanatory. So we are going to observe the last node if a node exists. And then once the new data gets loaded up, it's going to observe the last node. And then once we reach the bottom, the intersection observer is going to get called on its own because we are already observing that node. Basically, once we reach to that element, which is the last element, the observer is going to get triggered automatically, and it's going to execute everything that's written within this intersection observer code. Alright, so this is something an observer does on its own. Once we reach that element, this code is going to be executed, and since we reach that element, so that means that element does exist, right? And if you remember, I said the entries is going to contain all the elements that we are observing. So when we reach the end, the entries is always going to be including that last node, but just that when we reach the end, the is intersecting property that's present is going to become true, and then the page number is going to be increased on its own. If you're still confused, to help you out, what I can do is I'll just console log entries over here, and then you will understand what this is intersecting is. Basically, this intersection observer will include the entries or whatever we are observing, and each of those entries will have a set of properties. Those set of properties will be added by the intersection observer itself, and one of those properties is intersecting, and is intersecting is always going to be false until we reach that node. Once we reach that node, this is automatically going to become true. And to just show you what I mean, I'll go to my browser, I'll refresh this, I'll type TT, I'll wait for the results to come up, and then you see the results come up. Now I'm going to go to my console. Now since the results came up, so there is a last element. When there is a last element, this entries is already going to start observing that last element because we have that ref attached to it. So once the application re-renders, the ref is going to check for the last element again, and it's going to see, alright, there's a last element present now. And since we are only always observing one element, which is the last element, this entries is going to only include one element, and you can see this intersection observer adds all these properties to it, to the entry. And one of those properties is intersecting. And initially it's false because we haven't reached that stage yet. But once we reach that node, this is intersecting property is going to become true. So just to show you what I mean, since we are already observing this element to the last node, once I scroll down right to the bottom, you can see is intersecting. This gets called again, and for that same element, you can see the is intersecting is true now. You can see it was false, but once we reached to it, its property became true. Alright, so that's pretty important to understand. This is how the intersection observer works. For now, you just need to know the is intersection property. You don't need to know the other properties for this tutorial, but I highly recommend that you do understand what these other properties do as well. If you want to know what they do, just mention it down in the comment section, and I'll make a whole separate video explaining all of these properties one by one. Alright, and if you did notice, once we went to the bottom, the page number also got incremented and new data also got loaded. So we're pretty much almost done with everything. You can see new data got loaded, and if I go to the bottom again, you're gonna see, just wait for some time and new data is going to come up. You can see the scroll bar went up and new data got loaded. But now there's a few things we need to do. Whenever I type any query over here, it doesn't say loading, and that's not good design. We need to add loading over here. So what I'm going to do for that is I'm going to go down here, and right underneath this, I'm simply going to say div and then loading closed, and then if loading, then we'll just display a text loading. Alright, that's all. Now if I refresh this and I add anything ABC, then you can see it says loading first, and then once everything's loaded, this loading will go away and the data will appear. You can see the loading went and the data appeared. Same thing's gonna happen when I go to the bottom. You can see loading gets called again. We're going to wait, and then the data started coming back again, and the loading also went away. So that helps in making the UI better. The next thing we need to do is we need to add a property. We need to add another state basically, and we are going to name it has more, right? Has more, and this is initially going to be false. So this has more is just simply going to check if the API returns more data or not, or if the API has more data or not. All we have to do over here is I'm going to go down here to the use effect, and within this set loading, I'm just going to set has more. I'm going to say books dot data dot docs dot length greater than 0. So if there is more data, then has more is going to be true, otherwise it's just going to be false. And why are we doing this? I'll show you in a bit. I'm going to take this has more and I'm going to add it as another condition over here. Right, I'm adding and has more. So we want to increment the page only if we have more data and if it's intersecting. So if you're scrolling down to the bottom, intersecting becomes true, and it's also going to say if we have more data. If you have more data, only then we are going to increment the page. Because once you keep on incrementing the page and you reach the last page, then after that the is intersecting is always going to become true if you scroll to the bottom, but the has more is going to prevent us from incrementing the page number again, and that just won't call the API over and over again. So this has more is going to help us prevent that. Now we are mostly done with everything. I'll just remove this console log. Now the last thing we need to do is we need to add debouncing to this search system that we have made. Now how to do that? That's going to be pretty easy. For debouncing, all I need to do is, let's say I'll just add a global variable over here. I'll name it timer. Alright, and I'll take this timer, I'll go to my handle change. So this timer is just going to be equal to a set timeout. Within that set timeout, we just need to add a delay. Now that delay is going to indicate that after how long, that after what interval from when the user starts typing to when he or she stops typing, should the query be updated. Because once the query gets updated, we again call the API, right? So we need to ensure what time delay do we want, that once the user has stopped typing, then only after that we should call the API. So that's the reason why we need this timer. That's going to help us debounce everything. So what I'm going to do is I'm going to say timer equals to set timeout. All right, and then all I'm going to do over here is I'm going to set the query. I'm going to take this from here, to remove it from here, add it here. I'm going to set query, and then I'm also going to set the page to 1, because whenever we change the query, because whenever we are adding a new query, we basically want the API to show us the data for that starting from page number 1. So whenever the query changes, so whenever the input in the search box changes, we also want to set the page to 1. All right, now we also need to ensure that every time we come to this handle change, check if timer exists, and if it does, then we just need to clear that timeout. Clear timeout, and we're going to clear the timer. Alright, so this will ensure that our search gets debounced, because what's going to happen is every time you type something, so let's say, and before I explain you what this does, I forgot that we also need to add the delay over here. You can add this delay whatever you want. I'm going to add it as 1 second. So what this does is whenever I start typing first, right? So suppose I typed A, right? So it goes to the handle change, right? We are typing A over here in the input, it calls the handle change, but then it's going to see if timer exists or not. Timer, for the first case, it's going to be null. There's going to be nothing, right? Because we haven't initialized it with anything. Then after that, timer is going to be set to a set timeout, and it's going to wait for 1 second. Only after that 1 second gets over, it's going to go within the set timeout and it's going to update these states. But if I type ABC quickly, like within 1 second itself, if I keep typing ABC, then what's going to happen? So whenever I type B before that 1 second is over, it's again going to go to the handle change. It's going to say if timer is present. And yes, timer is attached to that previous set timeout for A. The previous set timeout that was assigned when we had typed A, the timer is going to be attached to that already. So when I type B, it's going to see that yes, timer already exists. So what we are going to do is we are going to clear that timeout. So that timer which was attached for A is going to be cleared out. So that set timeout for A won't be executed anymore. And then that B will be set to a new set timeout, which will again have a duration of 1000 milliseconds. Now before that 1000 milliseconds gets over, if I type C again, then again it's going to remove the timer for B and it's going to attach a new timer for C. As you can see, the timer keeps getting removed if I keep typing new queries before 1 second ends, and that's going to stop the set timeout from being run at all until we have actually stopped typing for more than 1 second. So if I write C removes the timer for B, it clears the timer for B. After 1000 milliseconds, nothing is going to run for B, and then C is going to be attached to a new set timeout, which is again going to wait for 1000 milliseconds. And this time if I stop typing, then after 1000 milliseconds, or basically after a second, it's going to set the query, and the query is always going to be ABC, because the e.target.value will always include whatever we have typed within the input box. So it's directly going to query for ABC, and the set page is going to become 1. So that's the specialty of this. After I've typed C and I stopped, the set query will be updated to ABC directly, and once the query changes, this useEffect will be called, and it's going to call this API again. So ultimately we are only going to be calling the API for the query of ABC and not A, B and C individually. And that is the power of debouncing over here. It's pretty simple and it helps a lot. It optimizes your performance, and in the long run it can also save your company some money, because it just makes everything cost efficient since you're not hitting the API endpoint multiple times. Just to test this out, I'm going to go to my browser, I'm going to save everything, and then I'll open my network, and then over here I'm going to type ABC. And you can see it's only calling this search once. It did not call it 3 times like it was doing so before. It just called it once, and then it loads all the data, and then once I go right till the bottom, the loading is going to be called again, because that's happening due to the infinite scrolling, and then it's going to wait for the new data to come through from the API. Once that does happen, it loads more data. We can scroll down again and again, and once we reach the bottom again, it's again going to load on its own, because it just incremented the page number. You can see the page became 3, and then it brought up more new data, and we can see more data come up. So the infinite scrolling works fine, the debouncing also works fine, and we have also implemented the search functionality in the proper manner. Just to again show you that debouncing is working fine, I'm gonna go to my code, and what I'm going to do is I'm going to set this to how it was before. So I'm just going to comment this out, and if you remember correctly, previously we just had this. Now you'll see what happens if I keep it like that. If I write ABC, you can see the API getting hit thrice for each of these letters. Now that is not a good approach, right? But if I just remove this, and if I uncomment the debouncing code, I save it and I go to my browser, then this time you will see what happens. I write ABC, it calls the API endpoint only once after we have stopped typing. And that is exactly what we wanted, and that also perfectly optimizes our search input. So this is all about the video. You learned how to create a search system. You also learned how to implement infinite scrolling to it. And lastly, you also learned how to optimize it by using debouncing on it. And all of this was done using React, and these concepts are going to help you a lot down the road as well. So this is all for the video. If you enjoyed it, then don't forget to like and subscribe. And as usual, stay tuned for more.